A compound inequality, so compound means more than one, just like a compound word in English means two words put together, is a pair of inequalities joined by an or an and. To solve a compound inequality containing and, find all the values of the variables that make both inequalities true. Look at the shading where the shading overlaps. So if you order a sandwich and you want mayonnaise and mustard, you want both mayonnaise and mustard on it at the same time on your sandwich. So you're looking for where it overlaps. So first example, graph the solution. 2x is greater than x plus 6 and x minus 7 is less than 2. So this is an and. So what I'm going to do is I'm going to solve this inequality, and then I'm going to solve the right inequality, and we're going to see where the red and the blue overlap. So solving here, I would subtract x from both sides. So x is greater than 6. So I'm going to go over here and graph. X is greater than 6. So we'll put 6 right here. It's going this way. And then over here I'm going to solve add 7, x is less than 9. So 6, 7, 8, 9. So 9 would be right here in open dot. So this is an and, so I'm trying to find where the blue and the red overlap. So the blue and the red overlap between and not including 6 and 9. So the answer would be 6 is less than x is less than 9. That's how I can write the inequality. So if you're shading in between, you can write the compound inequality as x is in between 6 and 9, and these inequalities need to go the same way. This is also an and problem, except for it's already written in this form. So what I'm going to do to solve for x, I'm going to look at what I need to do in between the two inequalities. So I need to subtract 20 first from the middle, from the right, and the left. So I get negative 30 is less than 5x is less than 5. Then I divide everything through by 5. So it's going to be negative 6 is less than x is less than 1. So I did not divide by a negative. I divide by positive numbers, so I don't change the direction of the inequality. So my answer is going to be x is greater than negative 6 and x is less than 1. So to graph that, I'm just going to graph negative 6, so 5, 4, 3, 2, 1, 0, and 1 right here, and they're both going to be open dots because these are open dots, and I'm going to shade in between because x is in between. Okay, example 3, I have another and, so I'm looking to see where they overlap. So this is going to be x is greater than 4. So x is greater than 4 right here. And x is less than negative 3. So about right there. Now where does the blue and the red overlap? Do they have any numbers in common? No, so they actually don't. So there's really nothing I can graph because there's nothing that overlaps. So you would just leave your graph empty and write no solution because there's nothing in common with x is greater than 4 and x is less than negative 3. Okay, on the other hand, when you have an or, you find all the values of the variable that make at least one of the inequalities true. So where anything is shaded is going to be an answer. So I'm going to solve for y. So I get 4y is greater than or equal to 16. Y is greater than or equal to 4. I'm going to solve for y in this one. So 3y is less than, adding 4 would be negative 9. Y is less than negative 3. So y is greater than or equal to 4. Close dot, shades this way. Or y is less than negative 3. 3, 2, 1, 0, 1, 2, 3. So y is less than negative 3. So my answer would be both of these. I just leave it like this. I'm not looking for an intersection. I'm looking for where anything is shaded. So anything that's less than negative 3 would be an answer. and anything greater than or equal to 4 would be an answer. So example 5, it has an OR, so I'm going to solve each one of these. So this would be x is less than 2, and this one I have to divide, x is greater than 8. I had to divide by negative, so I changed the sense of the inequality. So my solution is going to be x is less than 2 or x is greater than 8. Okay, number 16, a copper wire is to have a length of 16 centimeters. So you want the copper to be exactly 16 centimeters long, but with a tolerance of plus or minus 0.02. So that means that it's okay if you have a piece of wire that's 16.02 centimeters, or it could be 15.98 centimeters. Those two are okay. It's within a tolerance of plus or minus 0.02. How much must be trimmed from a wire that is 18 centimeters long for it to meet the specifications? So if it starts at 18 and you could get down to 15.98, you could cut off 2.02, but it could also go up to 16.02. So you could cut off 1.98. So you could cut, and I want to always write the lower number as an inequality. So you could cut off between 1.98 centimeters all the way up to 2.02. Number 7, the plans for a circular plastic part in a medical instrument require the diameter to be within 0.2 inches of 1.5 inches. A machinist finds the diameter is 1.73 inches. By how much should the machinist decrease the diameter? So it can be within 1.2, within and including 1.2 of, or 0.2 of 1.5. So that means that it could be 1.3 to 1.7. But right now it's 1.73. So how much could we cut off to get to the diameter? Well, we need to get to 1.7, so you could cut off anywhere between 0.03, and how can we get 1.73 to be 1.3? Well, that would be subtracting or cutting off, actually I should write it like this. So we could cut off 0.03 inches, or we could cut off 0.43 inches and still be okay. So I'm going to write this as an equality, putting the least number first. So 0.03 to x to 0.43.